half, I try to finish my class within 30 minutes because I think that 1 hour and a half should not, like, maybe not enough for you to do your midterm. Okay, after this, okay, I will try to do this, okay, because there's not much here, only clustering, discriminant, and also the trend analysis. Okay, not that much. Okay, so before that, okay, this is like a brief about your midterm. Okay, I repeat again. Oops, sorry. There are two sections, part A and part B. Okay, part A and part B. Part A is fill in the blank. Okay, I don't do matching because previously I think matching has a scoring issue. Okay, so I don't want it to happen again. So part A will be like multiple choice, fill in the blank, fill in multiple blank, and true or false. Okay, true or false, and also multiple choice. Multiple choice, you can choose A, B, C, D. Okay, something like that. Okay, so but fill in the blanks. Yeah, there's no option. Some of the question has options. Some of the question doesn't have options. So you have to type. You have to fill in using your words. Okay, you have to fill up using your words. Okay, and yeah. Okay, that's all. Okay, for part B. Okay, but for part B, there's a two question. So this one is like 25 points. So for 25 points, it like contribute for 50 marks, and this one also 50 marks. Okay, so for part B, there's two essay. Okay, there's two essay. Okay, there's two essays. Okay, one of the essays like contribute like higher marks, which is okay, there's two essay. One of the essay is 35 marks, another essay is 15 marks. Okay, so make sure that you, for 35 marks, I give you key points that what you should include in your essay. But for second question of essay, I don't give you any clue because I think that you can get it from your notes, but you have to write it using your own words. Okay, I don't, because we only have like very limited time, which is 2 hours, 1 hour and a half or 2 hours like that. We see how, okay. So because we have a limited time, so I didn't put how many words, okay, that you can write. So it is up to you to write as much as you want, okay. Please write it in essay form. Don't put it in point form, okay. Don't put it in point form. So make sure that if you want to elaborate, you can put like your topic, you can put your title, then after that you have to elaborate it in terms in essay format. Okay, okay, so that's all for your midterm. Okay, for your final assessment, also I did two parts. Okay, for your final assessment, I also did two parts. Okay, because this is a 1 week, okay, so they advised me to do like chapter 1 until 6. I thought that I want to do chapter 5 and 6 only, but they asked me to do, but chapter 1 until 6. Okay, so there's also section A and section B. Okay, section A, you will do a mini project. Okay, you will do a mini project, and section B is more towards essay writing, but longer. Essay, sorry, essay project, essay. Okay, so for essay, it'll be longer. Okay, I need like around 500 words like that. Okay, for mini project, I will give you data. I will give you a data, but you don't have to analyze it. It's not your job to do it. Okay, but the data, okay, the data that you will do is, I give you data and extraction of data. Okay, like, okay, maybe I give you like relation something like paper like this. Okay, like ID, maybe age. Okay, wait. This is like example, okay? Height. Okay, blah, blah. And I will give you the dimension of the data. Okay, so, okay, so to be, I will give you in Excel form. Okay, the data I will supply in Excel form. Okay, so the dimension of the data may perhaps will be like 200 and above. I haven't decided which data that I will use. Okay, I'm still drafting it. I keep on changing your question, to be honest. Okay, so from the data, okay, from the data, you have to analyze it as according as data miner. Okay, as according as data miner, you have to check, okay, but you have to write. You don't have to, you have to write, okay, if there's any, okay, I will give you what is your objective, okay. Okay, let's say here I want to find the factors that contribute to obesity. Okay, so using this data, you have to describe what technique of data mining that you want to do. Okay, so what is the pre-processing data that you have to do? You have to do the data scrubbing. You have to check for the outliers, the correlation, and all that. Okay, but you have to write it. You have to explain it step by step. Okay, so you have to explain it and what is the data mining algorithm that you want to choose to for it. Okay, whether it is like regression or time series or some summarization or association. Okay, so you have to describe at least three data mining algorithm. Okay, using this data, you have to explain it. Okay, but using this data. Okay, and after that, you have to discuss what is the outcome. I know that you're not running this data, but I want to discuss I want you to discuss how the outcome will look like. Okay, how you're going to present your outcome, okay, as a data miner. Okay, so that's for mini project. Okay, I decide to do only one types of data. Okay, but if let's say I found a suitable understand. Okay, if I found a suitable question for image mining, I will include that too. But so far, I haven't find any. I haven't find any image that is suitable to do for image mining. Okay, and for essay question, okay, they will be from chapter 1 until 6. Okay, so the essay will be longer. Okay, the essay will be longer. And there's also a paper review, but I will provide you the paper. Okay, I will provide you the paper. Okay, so I will provide you the paper and you have to do some summarization for that. Okay, for final assessment, I will release your question on 14th of October and the due date will be 14th of February. The due date will be 21st of February. Okay. Okay, so that is you have 7 days only to do it. Okay, so there will be essay and also a mini project. Okay, but a mini project, you don't have to run the data. You just have to describe, like explain, okay, what you're going to do, okay, using the data that I provided. Okay, I will provide the raw data in Excel. Okay, so yeah, that's all I think. I don't want to do any video this time around. So that is only for your final assessment. Okay. Any question? Okay. So let's get back to work. Okay. So clustering. Okay. I think I have explained like a bit of it during our first class. Okay. So clustering analysis is a data mining technique, okay, that is used to identify the object that contain similarities, okay, between each other in a group, but have differences with other objects in other groups. Okay, clustering analysis is very efficient if the data is unstructured, okay, and the analysis of the data in question is slow. Okay, clustering is very important in such situation as it comes up with some structure of the data by grouping data according to the similarities. Clustering analysis also help in handling high dimensional data and small size data. Okay, so actually clustering is, okay, you want to find, is there any hidden group in your data that lies in your data? Okay, so the best is, okay, as suggested in the note, that if the data is unstructured and no pre-information is obtained. So which means that the clustering will do analysis, then we found that, okay, this is the group. But not all not all not all data, okay, is unstructured. Usually we have a structured data, we already know the grouping. Okay, so we might revise, okay, our earlier grouping. Okay, clustering is like, yeah, like grouping. Okay, so actually there's a lot of clustering technique. Okay, this is in your note, there's like, yeah, 4. Okay, there's 4 technique of clustering. Okay, as clustering algorithm, but actually there's more than that. Okay, so wait, let me show you. Okay, so, okay, in my book, there's a lot of cluster, okay, involved, which has, it's not just not the centroid cluster, it has, okay, many cluster technique, which is the hierarchical algorithm, okay, agglomerative algorithm, okay, okay, this one, the divisive clustering. Okay, so actually we have to look at what types of data, okay, that you want to do the cluster. Okay, so if your data is hierarchical, we use agglomerative or decisive clustering. Okay, if your data is partitional, you have to use the partitional clustering algorithm. If your data is categorical, okay, yeah, we have a clustering for categorical. Okay, and if you have like large dimensional, okay, you can use sampling and also compression. Okay, but let's go back to your note. Okay, the first one is density-based clustering. Okay, density-based clustering is a clustering algorithm type that is used to group regions, okay, with high density into cluster. Okay, so it depends on the density. Okay, the data density, it depends on the set, then they group into the cluster. Okay, this ensure that these areas are connected to group. As long as the connection is there, the arbitrary shape distribution are allowed. So which means that it can be okay, it can be as like this, and this one is applied. Okay, it can be like this. Okay, and it can be like any arbitrary cluster group. Okay, so but it has major disadvantage that the difficulty is, okay, to handling data with variation in density and high dimensional data, and also we're not concerned about the outliers. Okay, so if they have like different density, okay, and if your data is very high dimensional, okay, and have outliers, you cannot use density-based clustering. Okay, so next type of cluster analysis is centroid-based clustering. Okay, it's centroid-based clustering. Centroid-based clustering is clustering algorithm that are used in the organization of data into clusters that are non-hierarchical. So which means that if the data is non-hierarchical, okay, we use centroid-based clustering. Okay, so it is efficient cluster, but for hierarchical data, okay, but advantage is very sensitive to outliers and the initial condition. Okay, one of the centroid-based clustering is k-means, okay, and also k-neighboring, k-neighboring. Okay, so k-neighboring and also k-distance algorithm, okay, so many other. Okay, but the commonly used centroid-based algorithm because it's efficient, effective, and also simplicity. Okay, so if your data is, okay, non-hierarchical, okay, you use centroid-based clustering. Okay, so I want to show you, oh, that's not here. Okay, so this is one of the example of cluster analysis. Another one is hierarchical clustering. Okay, so hierarchical clustering is similar like that classification, association hierarchical. Okay, hierarchical clustering is a clustering algorithm that create trees from the cluster data. Trees. Okay, from the cluster data. Okay, this algorithm is best suited for hierarchical data, okay, so especially data for like taxonomy. Okay, so the one major advantage of this clustering is that any number of clusters that can be chosen after cutting the tree. Okay, so this is like another example of the hierarchical clustering. Okay, so you see that, okay, if it is like, this is like taxonomy, right, for the animal. Okay, so animal is categorized, clustering into two, vertebrate and invertebrate. Then it go mammal, reptile, and all that. Okay, in hierarchical cluster, okay, in hierarchical cluster, okay, it is only suitable for the hierarchical types of data. Okay, it's only suitable for hierarchical types of data. Okay, and something. Okay, so this is the types of 6 elements. You see there, A, B, C, D, E. Okay, to be clustered. So, okay, so this one is 5 different sets of cluster. Okay, so this one has a single element, A, B, C, D, E. Okay, so part B, okay, where we have 4 clusters. Okay, so it's where like A, B, C, D. Okay, so part C, we shows that there's a new cluster formed by adding a closed element to one of the 2 elements. Okay, so you see that here, and this E combined with the other one. Okay, and D, okay, the 2 elements and the 3 elements are merged to give a 5-element cluster. Okay, so this is the 5-element cluster. Okay, and last one, okay, all 6 elements are merged. Okay, so this is like, we call it as hierarchical algorithm, okay, for clustering. Okay, so we have this one, 6 cluster, then the 4 cluster, 3 cluster, 2 cluster, and after that, we combine together, everything will be one big cluster. Okay. Okay, so another last one is distribution-based algorithm. Okay, distribution-based algorithm is a clustering algorithm that make assumption that the data is made up of distribution. Okay, what is made up distribution? Which means that if the data is followed normal distribution, if the data followed gamma distribution, if the data followed log normal distribution. Okay, so we use clustering, okay, by following the assumption of they follow what kind of distribution. Okay, so an example of such distribution is the Gaussian distribution. Okay, Gaussian distribution is normal distribution actually. It's another name for normal distribution. Okay, in the distribution-based algorithm, an increase in the distribution center would lead to a decrease in the probability of the data point belong to the distribution. If the type of the distribution in your data is not specified, it is advisable to choose a different algorithm. So which means that if you know your data, okay, is followed what kind, let's say followed normal distribution, okay, if you see that, okay, if there's any increment, okay, in the distribution center, okay, so which means that it's not belong to the distribution, which means that it belong to other distribution, so it's not normal. Okay, so if, okay, usually we use a Leibniz normality test and all that, okay, to see that, okay, this cluster is followed normal distribution, and for those who is not followed normal distribution, we can use a different algorithm for that. So we know that all of the cluster only followed certain distribution. Okay. Okay, so this is the one of the data mining algorithm, okay, which is the clustering. Next is the discriminant analysis. Okay, what is discriminant analysis? Okay, it is similar to classification. Okay, it is similar to classification, but this one is when the dependent variable is categorical and the independent variable or the predictor is interval. Okay, so discriminant analysis, okay, is a data mining, okay, to used by research to conduct analysis when the dependent variable, which is your y, is categorical. Okay, categorical means, okay, maybe nominal, maybe ordinal, okay, maybe binary, okay, and the independent variable or the predictor is interval. Okay, interval means you know that it can be number, okay, but it doesn't have the true 0 point. Okay, so categoricals are the dependent variables that are divided into categories, and the main aim of the discriminant analysis is to develop functions that are discriminant. Okay, the discriminant analysis have examined the significance of the difference that exists among the group in terms of the predicted variable. Okay, because our dependent variable is categorical, so we want to see, okay, we want to see our, which one is our independent variables is belong to our dependent variable. Okay, which one of the, so which means that if, let's say, okay, I have, okay, let's say I have type of accident severity. Okay, so this is my dependent. Okay, and I have other factor like age of driver. Okay, number of casualty, other attributes number of casualty. Okay, so types of this one I have fatal accident, serious accident, and also slight accident. Okay, so age of driver, I have the data. Number of casualty, I have the data. Maybe like whether when the accident happened, okay, I have the data. So I want to check, okay, where the age of driver here, okay, is belongs to, okay, it belong to, okay, this or this or this. Okay, a number of casualty which belong to which category. Okay, that is the discriminant analysis. Okay, so dependent variable categorical, but independent variable is interval. Okay, so we have few algorithm in discriminant analysis. The first one is canonical discriminant algorithm. Okay, the canonical discriminant is very suitable for a high dimensional data. Okay, it's very suitable for high dimensional data. Actually, all canonical, predictive, discriminant, and okay, are all the same. Okay, are all the same. We have more actually. Okay, we have more, but this one is only highlighted in your note. Okay, canonical discriminant analysis are algorithm that reduce the dimension of data by extracting a combination of linear set of quantitative variables that reveal the difference in the group. Okay, so for canonical, okay, they reduce the dimension. Okay, so you see that maybe this dimension is, okay, maybe this dimension is like maybe we have like 2000 data. Okay, 2000 data and attribute maybe like 10. Okay, so they will reduce from 10 attribute. Okay, we will know that it will reduce into, okay, maybe this one is only, it can reduce until only three. Okay, it will reduce only until 3 groups. Okay, so these canonical variables that are extracted contain a high possibility of multiple correlation with the group. The canonical weights are the coefficient of the linear, canonical weights are the coefficient of the linear combination. Okay, so it has many objectives. Okay, it has many objectives. Okay, some of it like, okay, so we want to test whether, okay, which group that is belong to. Another one is, okay, we want to see, okay, out of like 10 attributes, okay, which attribute that is grouping together. Okay, so maybe age, number of casualty, and also maybe like temperature of the day is grouped together. And another group is, okay, whether weather, rain, road type. This is another one group. So which means that from many attribute, it's only grouped into into a hidden group. Okay, that is based on the type of accident. Okay, so which means that out of 10 attributes, it can only simplify only until like maybe 4 groups only. Okay, so it reduced the dimension. So we know that we can, okay, we can do the analysis based on the smaller group. Okay, based on the smaller group. So this one has many attributes. Okay, so let's say that 10 attributes. So by using the canonical discriminant analysis, we can narrow down until 3 groups, which is belong to each types of accident severity. Okay, next is predictive discriminant algorithm. Okay, predictive discriminant algorithm is an algorithm that deals with multi-attribute sets and a classification variable. Okay, so the classification variable is a variable that contains 2 or more labels of grouping. Okay, so which means that this one is like multinomial, multi-group, or multi-level. Okay, this algorithm is used when the variable is nominally scaled and categorical. Okay, same like canonical. Okay, same like canonical, which means that the predictive, sorry, the sorry, it has multi-attribute sets and also the classification variables. So which means that we don't have any dependent or sorry. It don't have any dependent or independent. Okay, it doesn't have any, it has independent and dependent, but okay, it has 2 or more level of grouping. Okay, this algorithm is used when the variable is normally scaled and categorical, and it used to conduct classification on observation of the group that are predefined based on quantitative attributes knowledge. Okay, like in canonical, okay, we already have in mind, okay, how many groups that we want. Okay, same like predictive discriminant algorithm, okay, it is also the same. Okay, it is also the same. I want to show you. Okay, let me. Sorry. Oh, I want to show you the. Okay, so this is the output for like canonical discriminant analysis. Okay, so you see that. Okay, this is lowest functioning, highest functioning. Okay, this one also. Okay, the canonical analysis. Okay, so the predictive discriminant analysis also the same. Okay, so which means that, okay, we can narrow down, okay, from many from many attribute, it become, okay, only, this one is only for 3 groups. Okay, it's similar like cluster, yeah, but it's a bit different because our independent must be categorical. Sorry, our dependent must be categorical and independent can be interval. Okay, this one is not, this one flexible. Not many example for discriminant. Okay, so this is like kind of like discriminant output. Okay, so this is about discriminant analysis. This means that we reducing the dimension of the of your data. Okay, last one is trend analysis. Okay, trend analysis algorithm is very useful in time series and forecasting. Okay, so it is a technique, okay, used in time series to identify and collect the pattern in spots. Okay, so usually for trend analysis, it would be in, okay, in time series. So which means that we have the time value, we have the timeline. Okay, so this is a combination of the major data mining technique as techniques such as clustering, classification, and regression can be used. Okay, trend analysis is a method that used to predict the data based on the observation of the current trend. Okay, so a majority of the algorithm use this technique that we discussed in another technique. Okay, so for trend analysis, okay, usually we want to check if there's any seasonal trend. Okay, we want to check if there's any seasonal trend. Okay, if there's any outlier, okay, but it's all according to the time. Okay, so if then after that we will do forecasting. Okay, and we also can do the prediction by using the trend analysis. Okay, for forecasting, we have many other technique for that. Okay, we have any other technique for that. Okay, so yeah, okay, we have wrapped up data mining course. So any question? Any question?
No, Prof.
Yeah, I will increase the volume. Okay, yeah. No question?
No question.
No question. Okay, if there's no question, okay, give me 5 minutes. Okay, I will adjust your Europe, so that you're able to sit for your midterm now. Okay, but on your side, please be ready to turn on your camera. Okay, and start yeah, do whatever you any preparation. Okay, like suitable, like comfortable chair, suitable table. Okay, to do your midterm. Okay, give me 5 minutes. Okay, I will mute my microphone. Okay, but I will turn on my video. Okay, just wait for my announcement so that you can start your midterm after I announce it. Okay, please be ready in 5 minutes. Thank you.